looks like we're good to go. So welcome. Welcome to the Online Ethics Center Fall 2023 webinar series, Bringing Ethics into the Conversation. My name is Azita Hirsa, and I'm a teaching professor at the Rensselaer Polytechnic Institute's School of Engineering, the Industrial Systems Engineering Department, where I teach courses in management of engineering and technology, ethics of modeling, engineering ethics, and professional development, technical issues and solutions. I'm the chair of the ethics division at the American Society of Engineering Education, ASEE, and thrilled to be the webinar host for OEC's 2023-24 season. The Online Ethics Center, hosted at the University of Virginia, is a digital repository for resources on teaching and learning about ethics in engineering and science. The OEC also fosters a community of faculty and students, researchers, and other professionals who come together to discuss ethics. Please check out our website at onlineethics.org. The theme of our fall webinar series is Engineering Ethics in Industry. I'm delighted to host our speaker today, Dr. Francesca Rossi. Dr. Rossi is an IBM Fellow and the IBM AI Ethics Global Leader. She's based at the T.J. Watson IBM Research Lab in New York, USA, where she leads research projects and she co-chairs the IBM AI Ethics Board. Her research interests focus on artificial intelligence, with special focus on constraint reasoning, preferences, multi-agent systems, computational social choice, neuro-symbolic AI, cognitive architecture, and value alignment. On these topics, she has published over 220 scientific articles in journals and conference proceedings and as book chapters. She is a fellow of both the Worldwide Association of AI, AAAI, and the European Association of AI, EurAI. Dr. Rossi has been president of the IJCAI International Joint Conference on AI. She is the member of Scientific Advisory Board of the Future of Life Institute, the board of the Partnership on AI, steering committee of the Global Partnership on AI, and she chairs the 2023 AAAI/ACM Conference on AI Ethics and Society. She's also co-chairs the OECD Expert Group on AI Futures. She has been a member of the European Commission High-Level Expert Group on AI. She's the current president of AAAI. After Dr. Rossi's talk, we will take questions. To ask a question, please type it in the Q&A box at the bottom of your screen rather than the chat box, and I will read it to her. Audience members will not be able to use their mics or cameras. Thank you so much all for being here. Dr. Rossi, thank you for being here. So I'll give you the mic, and we are here to learn from you. Thank you.
Thank you, Azita. Thanks for the invitation and for the opportunity to discuss these topics with you and also with the audience. So let me share my screen so that I can, use my slides. Okay, so let me put a full screen. Okay, so today I'm going to talk about my point of view on where we are with AI ethics, and also how to operationalize these high-level principles around AI ethics that are very crisp and very elegant, but then they need really to be translated into very concrete actions inside the corporation, but in general, also in regulations or many other places. So first, I want to make sure that we understand how we got here with AI and where we are exactly. So here is very brief history of AI in one slide. I'm sure many of the audience know that we have been going through a lot of phases in AI. First of all, the term AI has been started being used in 1956. This is usually the date that we say the AI adventure in research started. So in the first few decades, we had logic-based or symbolic AI approaches. What does it mean? It means that we were telling a machine how to solve a problem by telling it exactly the steps that it had to do to solve the problem. So an algorithm was invented by a human being, and then this algorithm was coded into a machine to solve intelligently a problem. For example, this is what is used in the neural navigator. There is an algorithm that is in every AI textbook. It's called A*, that is used to find the optimal route from where you are to where you want to go among all the many different possible routes. Okay, so then AI researcher realized that this approach worked well in many cases, but it was not very flexible. It did not allow AI to be aware of the context in which it was operating and being flexible to uncertainty and many different variants of the situation. So yes, well for the navigator and for other cases, but not very well in other cases. So that's why we decided to add other techniques to AI, which are those based on data and examples. So the machine learning approach is an approach where we don't tell the machine how to solve a problem, the steps needed to solve a problem, but we give a lot of examples of problems and solutions to that problem. And we let the machine learn from those examples. So for example, here is an example that maybe in the US it doesn't work, but it is an Italian example, because in our highways in Italy, we have cameras that recognize and interpret the numbers and the letters on the target plate. And then they do it again like 20 kilometers later, and then they compute so that you identify the same car, and then they compute the average speed, to understand whether people go above the speed limit or not. But anyway, so this is a typical problem, reading something, being able to interpret well images that can be done with this approach and cannot be done with the previous approach that I described. Machine learning approaches were already around since the 1980s, but they did not have at that time enough data and enough computing power to be applicable. So that's why they came about, they were into the applications later than that. And very soon, machine learning was also evolved with many techniques, for example, the deep learning techniques, which allowed machine learning to do more complex things in terms of content interpretation. For example, face authentication or recognition, or also interpretation of our vocal commands. These was things that we're not able to do with initial machine learning, but yes, we were able to do with deep learning. Okay. So far in these phases, AI was able to, with machine learning or deep learning, to interpret well content generated by human beings. Now with generative AI, AI is also able to generate content itself, whether they're images, videos, text, or other things. So for example, this is an image generated from a very simple text description with DALL-E. Okay, so now these waves of AI brought about a lot of different capabilities that, for example, generated with generative AI, support the building of the so-called foundation models. What is a foundation model? It's just a generative AI model, very general, that, for example, it can deal with text, it can deal with images. Some of them are also multimodal. And it's called the foundation model because then it can be downstream transformed in a specific model that can be used for a very specific task. So here, for example, if you have a foundation model about language, then you can build downstream models for question answering, for sentiment analysis, for image captioning, if it has been trained on images, and so on. So this means that now the building of the foundation model requires a lot of data, a lot of computing power, and also a lot of time. But then once you have done with that, you can very easily and very fast build these downstream models that are the real models that are used in the applications. So with this scenario, of course, the phases in building an AI solution, the list of phases becomes larger. So you have more steps from the initial conception of what you want to do to the final AI solution, because you need to train the language model. For example, if you talk about language, and then you train on top of that the domain language model specific, and then you do the fine-tuning for the specific task, and then finally you have this function. So this creates more challenges, for example, from the regulatory point of view, because it's not clear who is accountable, who is responsible for whatever the downstream model is going to do. So responsibility assignment is much more challenges because of this more complex value chain in AI. But overall, of course, there are a huge impact into the application areas. And here you see some examples. We don't need to go through them, but just to give you an idea that really the impact of AI, of generative AI and foundation models plus the downstream models is really pervasive in all these things. It doesn't mean that we don't use anymore machine learning, which was not generative, or we don't use anymore the symbolic kind of AI, but really generative AI made a huge difference. Okay, so now we go to the risks, and some of them are legitimate risks. Some of them maybe they are a bit, we'll see whether they are exaggerated or not, but there are several legitimate risks in using the technology, in the uses of this technology. So let's start with the risk related to the behavior of the models. Okay, some of them, I will do this taxonomy about traditional, expanded, new, because I want to focus on generative AI, but I will talk about the risk of AI in general. And I call traditional those risks that were already very well known before generative AI was in the picture, but now, they are also present in generative AI. Of course, data privacy and data governance is always very important. And this is obvious because, of course, AI, and now even more, requires a lot of data. And a lot of this data, it may be a personal data, which is in some sense a good thing because we can get a personalized service, but of course it needs to be treated with care. So privacy is very important. Transparency and explainability also is very important, and this was already an issue with traditional machine learning approaches. But some of the issues have been expanded with the use of generative AI. And for example, we find robustness is expanded because now we have more ways to attack, and discover, for example, vulnerabilities of these models, which are, carefully writing the prompt to a large language model to bypass whatever guardrails have been put in place. So before, robustness was an issue, but now it has been expanded. The second one is fairness. Of course, fairness was the most well-known issue, I think, in machine learning approaches. But now it's even expanded because not only bias issues are because the model can be trained on data that is biased and so can make decisions or give recommendations that are biased and can create discrimination, but even the content that the model generates may include in the content bias and discrimination. So request, for example, the text that a large language model produces, it may include bias or stereotypical description of certain groups of the population, or the image that is generated from a text description may be biased, like you require, generate an image of a doctor, it can be all men because there is this bias in the system. And the other one, as I mentioned, is accountability. Accountability was always something that we needed to understand how to deal with. But now, as I mentioned, because of this longer value chain, foundation model, downstream model, training, fine-tuning, and so on, it is even expanded. But there are completely new risks. So one of them is value alignment. And value alignment in some sense includes fairness, because fairness is an important value for us, but includes also other things. For example, the possibility of these large language models to generate text that is toxic, harmful, offensive, so it does not align with some important values on how we communicate with others, how we respect each other. So the generation of content introduces these new issues about value alignment in the content that is generated. And the new one is about data disclosure, confidential and covered by IP protection. And why is that a risk? Because I can have a dialogue with a large language model, and in the prompt I can put information that is private or confidential, and in some cases, that information that I write in the prompt can be used to retrain later on that large language model, and therefore the large language model can generate it in part or exactly the same to other people that are going to have a dialogue with that model. So at the end, what I wrote in the prompt in my interaction with the model goes being disclosed to other people. Another related behavior related to confidential data disclosure or IP issues is that, of course, the training data could contain content, for example, text, like books or others, that are covered by copyright. So if you take these in and you put them in the training data, then the model can generate data that is covered by copyright, because it can generate part of the text that comes from the training data. So these are issues that are new because these systems can generate content. The next issue is misuse. So these models are very good at combining the pieces of the training data that usually come from various parts of the web, and combining them in order to answer, a question that somebody wrote on a prompt. And so they could be used by bad actors to learn how to do things that maybe have a negative impact. For example, somebody could ask a large language model instruction on how to build a bomb, for example, how to build a bioweapon, or how to make a cyber attack. And maybe that information in pieces can be found scattered here and there on the web, but we would not be able to put all the pieces together as a large language model can. So in some sense, it facilitates this possibility of bad actors having instruction on how to do bad things. The last one is the misinformation. And this is because of a limitation of large language models. So large language models can generate content, text, that is not true. But that looks like is true, meaning that it can generate a piece of text that is not factually correct, but syntactically is perfect in how it's written. And why can a large language model do that? Because that's technically called hallucinations. And the reason is that these large language models are actually not trained to distinguish what is true from what is false, but are trained to do just one thing, which is to generate the next most probable word, given all the words, like 3,000, depends, on the number of words that have been generated before that word. So in the training process, the large language model builds this probability distribution on the words, and then every time it generates the next word, it generates the most probable next word given the previous words that are generated, and then the next one, and then the next one, and then the next one, and so on, and then it creates the whole text. So by doing that, it may put together pieces. It may be that the next most probable word, and so for the sentence, comes out to be incorrect, even if, so incorrect, false, even if everything in the training data is correct. So that's, that's the mechanism where some people say the large language model lied to me. No, it didn't lie to you, because lying means that it knows what is true and it's telling you something false. But the large language model doesn't know what is true and what is false. It just generates the next most probable word. And it's surprising that just that goal in the training phase allows the large language model to have a perfect model of the natural language, because a large language model writes correct English or Italian or sentences syntactically. But the semantic, the correctness in terms of the semantics and the false or true content, that is not something that the large language model can do. So sometimes, not every time, sometimes it can generate incorrect information, but it looks very true. So that's difficult for people people need to check. But they need to be aware of these limitations. You may have heard, for example, that a lawyer in New York, not aware of these limitations, presented to the court 6 precedent cases which were completely made up by ChatGPT. And not because he was a bad lawyer, but because he was not aware of these limitations that creates these risks, this risk of generating misinformation. But of course, the real risk is that misinformation can be disseminated. There can be bad actors that want to disseminate misinformation, and that can be very bad in general, for not just for one individual or one lawyer, but in general. Okay, so there are also risks related to not just the properties of the technology, but also the societal impact of using these models. So, of course, the impact on jobs. Many more tasks can be automated. Again, because of the current limitation, you still to have people in the loop, of course, but definitely there is an impact on jobs. There was already with previous machine learning, and there is now even more, even on jobs that are creative jobs, and because now they can create content, and even and in jobs that, in all the jobs that have to do with language, while before we didn't have that possibility of using a machine to help generate text. Also, there are other risks about the exploitation of human beings to do the kind of jobs that are needed for building an AI model or an AI solution. For example, in supervised machine learning, so classical machine learning, you need people to label the examples in the training data. In generative AI, that is not needed because it's unsupervised machine learning, but you need people to help mitigate the kind of content that can be generated, the offensive or toxic nature of the content. So people are asked to look at the content that is generated by an AI, by a large language model, and to say, oh, this one is more offensive or less offensive than the other one, which so this very low-level work that is very low paid, paid very little, and that can be even disturbing for human beings, because you have to look at very offensive and violent, text in order to say this is not good. And so there is a question about exploitation of human workers that are related to AI tasks. There is also an impact on the environment, especially with generative AI, because as I said, the training phase requires a lot of data and therefore a lot of energy and computing power to train on those data. And also the next one is about homogenization, which means that the large language model, in some sense, takes information from all over the web, written by people that come from all possible cultures, and puts them together and then generates like some mix of all of them. So that doesn't recognize very well that there are different cultures and different points of views. It just puts everything together and generates words in the way that I told you. And then there can be also impact on human agency. So the fact that we leave AI to make decision. Okay, you generate content, you make decision, and then we are left, without not having enough human agency and control on our decisions. And then there is also the impact on societal structure because of the fact that AI can generate misinformation, so false content. Then this is, for example, deep fakes, another thing, in the domain of image generation. These also videos. This can greatly impact negatively on the structures of our society, like on the legal system that needs to understand what is true and what is false. So a proof is a proof because you assume that what you see in a picture is true. But then if that assumption doesn't hold anymore because the picture can be generated by an AI system and it can be false, then the legal system is, it needs to understand what to do about it. Democracy, elections, generating misinformation can change the opinion of people that are going to participate in election, as well as the impact on education. More and more, the education system needs to understand what to do with the possibility of students of using these tools to do their tasks, their assignment tasks, and possibly to change the way we teach and the way we evaluate students as well. There are also some long-term issues that are also sometimes called AI safety instead of AI ethics risk, and they have to do with the loss of control. So systems that can self-replicate or self-improve. We are not at that stage yet, but it could be in the future. What is called also the irreversible proliferation, meaning that AI that can be acting in a way that is harming or harmful for humans, but that we cannot have the ability to terminate because, for example, it has been replicated billions of times. And then the so-called rogue AI, which is really, really very much, speculative risk, where AI learns goals, internal goals that are disaligned with respect to our values to achieve the objectives that we give to AI. So even if we tell AI to do something very simple, but then in order to achieve that goal, the AI could learn that it has to do these other things, and these other things could be not aligned to our values. So let's go to AI ethics. AI ethics is as a goal that is very simple state. Take the best out of this technology and try to mitigate the risk. And the most important thing about AI ethics is that, in my view, that of course this mitigating these risks that come from this technology and its uses cannot be done by technology experts alone. It is a very multidisciplinary field where many other experts or many other disciplines have to be involved. And this is because these issues are not just technical issues, they are socio-technical issues, so they require socio-technical solutions. So yes, software tools are useful to, for example, detect bias and mitigate it, or to do, offensive content mitigation and so on. Tools are out there and they are improving. But you also need education, multi-stakeholder consultation, team diversity, policies, and many other ingredients in complementary methods and mechanisms to address these issues. So over the years, AI ethics field has evolved. At the beginning, when machine learning started to be very pervasively applied, we had few years where people were trying to understand what the issues were. We're looking at algorithms, say, oh, this algorithm is biased, like the Compass algorithm 2016, Then once people realized that there were issues, everybody was writing principles. So we had more than 100 sets of principles written by all possible organizations, corporations, governments, academia, multi-stakeholder organization, and so on. And then we moved on to the practice phase, where these principles were translated in one way or another into some concrete actions. But now, in some sense, these three phases that were so sequentially done until 2019 and so on, now they are all mixed, because now technology evolves very rapidly, new issues are recognized, so new principles and new translation from principle to practice all happening at the same time. So what does it mean to operationalize AI ethics? So the first thing important to me is that it cannot be done by one societal actor only. All societal actors have to play a role in this operationalization of the principles of AI ethics. So governments should understand how to best regulate AI. Companies should understand how to best build and use and deploy AI. Research labs where to direct the research in order to address the risks. International standard bodies, educational institutions should educate people and the next generation of technologists to also understand the impact on society. Civil society organization, media should communicate in a responsible way what happens around AI and not build hype around AI, saying, oh, we are there, AI is like a person or whatever, things that are definitely not true. And then each of us, each user, even if people that don't have anything to do with technology in their professional career, they have to play their role. We need to use AI in a very responsible and conscious way, while we tend to be a bit passive in using the technology and getting the best that the technology can give us, and give to the technology a lot of the decisions in our life. And so kind of I'm sure many of you have seen the movie Wall-E, kind of that scenario where people are just doing nothing, just watching movies and drinking some drink, because the technology takes care of everything. So we need to be much more aware and conscious when we use everything and we use AI, by the way, all the time. Now people perceive that AI has arrived now because they can interact with ChatGPT, but AI has been around with all the other techniques for many years, and all of us have been using it, even though it was a bit hidden inside the services that we were using. For example, every time we use a credit card, for many years already, there is an AI algorithm that checks whether that transaction is fraudulent or not. Or every time I said that we have target plate recognition or many others. So spam filters, web search, everything we do online is done using AI already for many years. So let me see how I'm doing. Maybe I should go a little bit faster. So we did some study to understand what companies have been doing to address the AI ethics issues. So let me just give you two points here that we saw on the study. We interviewed more than 1,000 companies, and here is we really saw very clearly this intention action gap, as is called by the World Economic Forum. So what is the intention action gap? It means that if you see here below in the x-axis, you see many different issues around AI ethics, and then the blue line says what's the percentage of companies that says they have endorsed principles around accountability, transparency, and the other thing. But the green line says what's the percentage of companies that have done something about it. They have translated these principles into something. And you see that there is a big gap. So it's very easy to endorse a principle, but now it's much more difficult inside the company to learn. This one is another point that is very important to me and very promising. So we did two studies, 3 years apart from each other, and we asked the same question: who is responsible in your company for AI ethics? And in the first study, they mostly said the CTO, the Chief Technology Officer. Okay, 3 years later, fortunately, many of the companies said, no, now it's a board level, CEO level. So they understood that AI ethics in a company is not just a responsibility of the technology part, but is a company-wide responsibility. And that, I think, is the right trend. So the other thing was not such a good news, but this one is more of a good news, that trend. So let me focus a little bit again about what companies, why companies should care or spend money, resources, people around AI ethics. And some companies may think that is only about regulation compliance. So they would say, oh, regulation doesn't force me to do these things, so why should I do them? When the regulation will come, I will be compliant. I will put in place what is needed to be compliant with the regulation. And of course, this is one approach, but it's very short-sighted, and also I don't think is very successful for a company, because there are many other reasons that can convince that it's good for a company to spend time and resources on AI ethics, company values, but also company reputation, social justice issues, of course, but also client and investor inquiries and requests. You know, our clients ask us all the time, because our clients are other companies, and they also work in very regulated domains like healthcare or governments or even financial institutions. So they ask us, oh, you're giving me this piece of technology, but did you take care of bias? How did you take care? What test did you did? So client and investor inquiries are very important, as well as client trust. If we give something to a bank, and then the bank uses the piece of technology, and then the clients of the banks complain that they're not treated fairly, then of course the trust in us is going to be damaged. As well as business opportunities, because of course, again, there is this trend of embedding, values and addressing these issues. So companies that don't do that are going to be behind also in the business opportunities. So what we did at IBM, very briefly, we started like everybody from very high level principle. Purpose of AI is to augment human intelligence. Data belongs to their creator, which is in our case is our clients. And then they focus on transparency and explainability. And then we said, what do we do with these principles? Nothing, basically, because our developers, our sellers, they can't do much with this high-level principle. So we have to go down at least one level to go and say, okay, we focus on 5 main pillars that now we are, by the way, augmenting with other ones because of generative AI. But already with machine learning, we said we focus on these 5 pillars: explainability, fairness, robustness, transparency, and privacy. So everything we do around AI ethics is translated into action that have to do with these 5 pillars. So the first thing we did was to build these toolkits to allow our developers to address each one of the pillars. So you see a toolkit on explainability, another on fairness, on robustness, on fact sheet is on transparency, then you have on privacy, and so on. So tools that help developers understand what they can do to address these issues while they're developing an AI system. But again, as I said earlier, the tools are not enough. They are needed, but they're not enough, because we were given these tools and the developer said, when should I use the tools? How should I use the tool? So we really needed to change the culture of these people. And that's why we put together a lot of other initiatives: education, diversity, playbooks, assessment, with a centralized governance that could make all these initiatives coordinated. Otherwise, especially in a large company like IBM, you would have all different initiatives following different, possibly contradictory things. So that's why we put in place the AI Ethics Board, which is chaired by me and by the Chief Privacy Officer, that is very well positioned in the organizational structure of the company and is very well connected with all the business units. And the board, there are representatives of all the company business units. So we don't have an AI ethics team. We have an AI ethics board where all the business units are represented. And also this board is not an advisory board, it's not a consulting board. This is a board that makes decisions. If a deal is not right, it doesn't get signed. So, but we got to this place through some evolution. It wasn't getting 1 minute, but that's where we are. And so to give you an example of some of the work stream of the board, so the first one on the top left is tech ethics by design. We help our developers understand how to use those tools into the various phases of the AI development. The second one is the use case reviews that is about assessing whether an AI solution that a team wants to develop to a client, wants to deliver to a client, is done according to the tech ethics by design playbook, but also is deployed in a way that respects and is aligned with our principles. Regulation readiness, education, a lot of educational material for everybody at IBM, but also much more deep, of course, on AI ethics to those that build AI solutions, a work stream of foundation models, a work stream of understanding what we mean by augmenting human intelligence. That doesn't mean that nothing is automated, but it means that you want to augment the way the humans make decisions in whatever they do. One on neurotech here, because we also look at the interaction of AI with other technologies, such as neurotech. And this interaction is what can bring additional ethics concerns. So, for example, AI plus neurotech can bring additional risks that we haven't talked about human identity and mental privacy. Those, if you look at AI alone, you don't see those risks, but AI plus neurotech can show you that there are these additional risks. This is a bit more detail about our use case assessment process. So every team that wants to build a solution for a client has to evaluate the AI ethics risks along the 5 pillars that I mentioned. And then there is a person, a focal point of the board in that business unit that evaluates the risk and decides whether the risk is very minimal or none, so that it has to be, that doesn't need the discussion with the board. Otherwise, is brought to the attention of the board, and the team comes at the board meeting and describes what this use case is, what this AI solution is. And then we, together with the board, we try to understand whether it's fine as it is or whether it needs to be changed, more tests needs to be done, or we need to put some conditions, for example, in the contractual agreement, like impose restriction on how these technology is going to be used by the client, or we want to impose some education for the users. So all sorts of ways that we can improve the AI ethics satisfactory level of these solutions. So we do this internal, in some sense, assessment. First of all, the tech ethics by design that allows to assess internally with benchmarks and tests and thresholds whether the models that we built are addressing well these risks. Then we have the review process for the use cases. Of course, we have regulatory compliance for the existing regulation and already preparing for the regulation that will come, like the European AI Act. And then we are adding also a red teaming model evaluation, because so far, the model evaluation is done by the same team that builds the model. So it's not done in an adversarial way. The team that builds the model takes up some benchmarks and tries to evaluate and test for bias, go above a threshold, and so on. But we also are adding some red teaming, mean adversarial evaluation from other people, internal, but also possibly external, for the model that we build. We really also believe that it's important to work not just internally at IBM with all the business unit, but also with other stakeholders externally. So that's why we work with policymakers, with other companies, with the civil society organizations, with standard bodies. So you see here some of the partnership that we have with many other stakeholders. around AI ethics. The last thing here that I want to mention, that recently IBM has released a platform to build AI and especially generative AI solutions. And this platform, I don't want to describe it, but I just want you to notice that it has three main components. One is the data. Of course, you need the data to train these AI models. One is the AI, so models that are trained through the data and they build the AI solution. But the third one is the governance. And this is where all we learned about AI ethics is embedded. So, and this is just to say that the governance and the ethics part is not a nice to have, is not something to put if there is time, is as important as the data and the model. So it's at the same level, and building an AI solution at this point, it cannot just be give me some data and I train an algorithm and this is the solution. It has to do also with understanding the issues, the limitations, the risks, and building a governance around it. So overall, some lessons learned in these years on operationalizing AI ethics. So the first one I already mentioned. We've seen companies that have AI ethics teams, and these teams struggle to have an impact on the rest of the company because they're not integrated in the other business units by design. And that's why we have a board and we have a company-wide approach to AI ethics rather than a team. The second one, I also already mentioned, a governance body that is not advising or is not giving suggestion or recommendation, but is making decisions because you want, to be able to make decisions, even if sometimes the teams do not like those decisions very much, but more and more we are trying to make these teams understand that the board is not there to don't allow them to sign a deal, but it's there to help them make a better deal for us and also for the client. So third one is about the full operationalization of the principle. It means that the principles are fine, but they're just the first awareness, first step, and then you need all the other pieces. Technical tools, definitely yes, but also all the other mechanisms, processes, internal processes, education, the risk assessment, the governance, and so on. Regulations are important, as I mentioned, but really AI ethics is beyond compliance. And as I mentioned, the company should be convinced that to spend resources in AI ethics beyond the fact that there is or not a regulation that requires that. Again, the value of the multi-stakeholder partnership, well, we learn what others are doing from other stakeholders also, and we bring our experience. And right now, everything is evolving. So AI is evolving very rapidly, much more rapidly than before. So the AI ethics frameworks need also to evolve very rapidly. And then the role of AI research. So IBM has a very large AI research component that really supports the advancement in AI capabilities and also in AI value alignment and addressing the risk. So most of the tools that I showed you come from the IBM Research Labs. So the connection, very strong connection between the research labs and the platform or products or solution that we provide. So I will stop here. Even though I have a few slides about the EurAI Act, but I guess we can discuss it possibly in the discussion.
Awesome. Thank you so much. I could listen to you all day. This is really great. I genuinely appreciate it. We do have a couple of questions. The first question is, as someone who has a professional relationship to an organization that regulates engineering, it's very troubling that there is so much gray areas about whose responsibility it is. What insight can you offer about how lines of responsibility are being or should be negotiated and clarified among so many stakeholders?
Right. So, so if you look at the European AI Act, for example, it addresses a little bit this complex value chain issue, no? That you have those that label the data, the training data, those that build the large language model, and then those that build the domain specific large language model. Then the other team that builds the task specific downstream model. So, and then finally the solution. So the European AI Act, for example, defines some scenarios that are high risk. And then it says, oh, if it's high risk, you have all these obligations to have to do. And so it tries to assign these obligations to the various actors, but I didn't see a very well defined yet, and maybe in the law itself it will not be included, but then later on, before the law is actually adopted, it will have to be included in some other document, because we believe, for example, that only when you know how the AI is going to be used, so the task for which is going to be used, you will know whether it's high risk or not. You will know what is the right definition of fairness to use, and therefore the kind of bias that you need to mitigate. So, for example, those obligations related to that should be downstream, should be in the downstream part of the value chain. Those that build the large language model that then is used later on for the solution will not be able to even assess, what fairness should be achieved, because this can be used in so many different ways, and also because it can be used for high risk scenarios, but also for very low risk scenarios. The same large language model can be used, I don't know, to recommend the next movie to watch on Netflix, or it can be used to recommend the therapy for a patient. So, of course, the risk is much better understood in the downstream phases. And so we think that the obligations should be more downstream, but of course, those that build the upstream part of the value chain should communicate and share knowledge and information about how the system has been trained, what test it has passed, what kind of data is being used, so that those in the downstream parts can comply with the obligations of a possible regulation. So it's a complex thing, and I don't think there is a very crisp solution so far.
Thank you. Can the deployment of AI itself, regardless of its form and application, be considered harmful to human culture if it leads to reduction of human interactions and lesser need for trust and strong social bonds?
Well, that's part of this societal impact, no? That in some sense, we don't need generative AI to have that effect, So already with the current technology, we spend more time on our phone than ever before, right? Instead of talking to people and interacting and going out and having dinner with others and socializing and so on. So definitely, that's why I said that every individual using the technology needs to make an effort in using it responsibly and being aware that in the long term, and not maybe too long, this can be very detrimental to the structure of our society. And one structure of our society is socialization. We are social animals. So if we use the technology to remove that part of our essence, then we need to be aware of that. We cannot just be like what's the story of the frog in the boiling water, no? And then at some point say, oh my God, then the water is boiling, then we have to be conscious since the start, if I use, and in some sense, some technology has been, so there are some alerts, no? For example, in my phone, every week, I get these statistics of how many hours I spent on social media, how many hours I spent on, I don't know, on web search or on the other things. And so that's a little bit of making him more aware of what I'm really doing with the technology. But I really think that we should make an effort. So I always say that AI, some people think that AI is like an asteroid, something coming from an alien. AI is not like something coming from Mars. We build it. but we build it, we use it. So that's good news. It's not something that we cannot control. We can control it. But of course, the bad news is that we have the responsibility to use it and build it in the right way. So we need to make an effort. And yes, I agree that that's a danger that is already taking place. And we need to, do what we can to, in all our respective roles, but also every individual, to make sure that it has the right impact on our life.
Thank you. Next question is, how can someone using generative AI models navigate the fact that some outputs could be covered by copyright or other legal protections? Do you view this as the responsibility of the users, the model trainers, providers, the database builders, or some combination of those?
Well, you might have seen that IBM and also other companies have released models taking responsibility of possible issues with the generation of copyrighted information. But I think that another approach, which I think it would be even better than that, because it would be to prevent that there are issues, rather than saying, if there are issues, then I will cover, no? But to prevent, and that, of course, can be done by doing some filtering in the training data, of course, and in coming up with new ways of tagging and understanding and being able to disclose the provenance. So when a content is generated, it would be ideal to understand where it comes from. And that could help us in also avoid these issues with copyright information. There are also some issues of copyright, even in open source content that is released open source, because in some open source licenses, you can use the content in any way you like, but you have to mention the person or the organization who released it. And of course, this gets lost in the training and then the generation of content by the large language model. So definitely that's an issue that I think we should try to approach from with the solutions that try to prevent it, with filtering data or with other provenance tracing mechanisms. Besides, being responsible and covering for whatever issues comes out.
The next question says, thank you. I really appreciate your presentation and time. The progress that you've made at IBM in ethics in ML AI is very impressive. How can this be brought out of the corporate scope to the world community? How can we motivate the world's population to care and use their purchasing power to influence other companies to adopt these or similar principles? And then how do we as world community monitor compliance?
So first of all, there are a lot of organizations that are very multi-stakeholder where civil society is very present. For example, the Partnership on AI that we co-founded with other companies in 2016 now has about 100 partners, of which 20 are companies, only 20. And then there are all academia, all the research labs, civil society organization. For example, ACLU is very present in every project of the Partnership on AI. So whenever the Partnership on AI delivers something, like recently it has delivered the guidance for foundation model deployment, it is done with input from all these different voices, and not just from technical or corporate organizations. So that's the way I think that civil society organizations can impact what really is done. And for example, another example is that the European Commission, before starting to draft the European AI Act, it put together this high-level expert group on AI that I was part of. This were 52 people, very diverse. There were advocacy groups, there were consumer rights organizations. There were all sorts of other people that were not experts in AI, but they were experts in what consumers' rights are, what societal impact means. And so then that group developed the ethics guidelines for trustworthy AI in Europe that then the European Commission used to build the draft of the European AI Act. So there are ways that the civil societies really connect more and more. And I think that everybody, I mean, I don't think that any corporation could say that we want to do things by ourselves and we make decisions by ourselves. Maybe some corporations still, but more and more, I think that this multi-stakeholder approach is used.
So, and I'm going to ask you one last question, and I know we're over time a little, if that's okay with you. Do you envision that AI ethical behavior enforcement can be automated or give a red, yellow, green context-specific grade?
So the behavior of an AI system, you mean?
I believe that's how I read it, unless you want Bob,
Okay.
if you want to elaborate on that.
So so again, for example, humans are so far humans are used to grade, for example, the generation of the text of a large language model. No, this is a technique called reinforcement learning with human feedback, because humans are given examples, are given pairs of text generated by the large language model, and then the human is asked to say which pair is less offensive. And then another pair, another pair, another pair. And then based on this human feedback, we build an AI system, reinforcement learning system, that then is used to help the large language model that has been already built to generate less offensive stuff. Because that model gives a score which is higher if the text is more offensive, lower if the text is less offensive, and this score is obtained through this human feedback. So in some sense, we use something like that, but it's not a really ideal scenario, because it would be ideal to embed this, making sure that it does never generate offensive content, rather than building it and then giving the score and then making sure that he understands that he has to minimize the score. So there are ways to score but it's based on human feedback, which has its own challenges, because of course these humans may have different opinions of what is offensive or not. They may come from different cultures where offensive means different things in different cultures. Even, explicit pictures, whatever, they mean different things in different parts of the world. So again, homogenization of putting all these humans together then do this kind of job to train to improve the behavior of the AI model. But yes, there are ways to give scores.
Awesome. Thank you so much, Dr. Rossi. I could have kept you here all day, and I really appreciate the fact that you've spent this time with us and got us to learn quite a bit today, just in the hour that we had, and we went a little over. So thank you. Thank you again. And I want to thank, absolutely. I want to thank the OEC's director, Dr. Rosalind Byrne, and our coordinator, Courtney Walker, who's been sitting in the back patiently and moderating things, and to all of you for joining us today. And we hope that you took away something. We will have a recording of this, so we will definitely share that with you. I do have one question before you leave. I had an earlier question. Someone wanted to know if it was okay to share your slides with students. And of course, give credit for it if that would be all right.
Sure, definitely. Okay.
Awesome.
Thank you.
Thank you. Have a great day.